This video will demonstrate how to use SPSS to obtain measures of central tendency, and in this case in particular the mean, and measures of variability, and for our purposes the standard deviation. So what we can do is we can go to Analyze, Descriptives, and then Descriptives. And what we want to do is take our interval level variables and move them into the variable box. So GPA is an interval level variable. Quiz 1, quiz 2, 3, 4, 5, final, and total. Those are all interval level variables. It really doesn't do us any good to move over gender because gender is either male or female, and so an average value for gender is not going to help us or to describe any characteristic of that variable. Just like ethnicity. Ethnicity is categorized as Caucasian, Black, Hispanic, Asian. And to get an average value for ethnicity is really fairly meaningless. But for our interval level scores, to get an average GPA, an average quiz score, an average of the total and the final scores is a perfectly legitimate use of the descriptive procedures. And if we click on options, we can see that the mean is checked, the standard deviation is checked. If you wanted the variance, you could get that. If you want the range, that's the difference between the largest and the smallest value for a variable. And then in terms of the distribution, the shape, the kurtosis would be how peaked the variable is, and the skewedness would be are the scores shifted to the right or to the left in terms of normality. And so we can go continue and then OK. And so you get one table, and you can see the range, and the range is the difference between the largest GPA and the smallest GPA. You get the mean, the standard deviation, and then the skewedness statistic and the kurtosis statistic. One of the ways that you would know if the skewedness and kurtosis is significant or not is if you divide the standard error into the statistic. If it exceeds plus or minus 2, then that would say that the skewedness value is significant. And likewise for kurtosis, if you divide the standard error into the kurtosis statistic and it exceeds plus or minus 2, then we know we have a significant kurtosis. Now, if you want to look at the descriptive statistics by group data, then we can go to Analyze, Descriptives, and Explore. And in this case, let's say we want to look at the descriptive statistics, or the mean and the standard deviation and the other skewedness and kurtosis for total. So we put total in the dependent list, and our factor list would be our grouping list. So let's look at total scores by males and females. And if we click on statistics, we notice that the descriptive statistics are checked. And then plots is an important one to check because we can get the histograms. The stem and leaves don't tell us that much. They're like a histogram on its side. The box plots I usually don't check, but I do check the normality plots. And the reason I check those is because it gives us a test of skewedness and kurtosis for these group level distributions. So if we go continue and then OK, we see that we get our table, and for the total score, the female mean is 102. The standard deviation is 13.896. And of course you get all these other values. The male mean is 98.29, and the standard deviation is 17.196. And when you check the normality plots, the most important thing that you get is a test normality for each group variable. And so if the significance value exceeds 0.05, which this one does, what this tells you is that the female distribution of total scores is significantly non-normal, whereas the male is not significant because this value is not below 0.05. And so let's look at the female histogram. You can see it is skewed to the right. And so this means that the total scores are sort of piling up on this upper end, whereas the male scores are somewhat skewed, but you also have this what we call a bimodal distribution because you have two peaks here. So this is how we can get the descriptive statistics not only for our total overall variables, but then also by male and female.